Hey, and welcome back to another LeetCode video. Today we're looking at the math and geometry section of the LeetCode 150 list. And the first problem on that list is the rotate image, LeetCode number 48, medium problem. And yeah, let's try to solve this. I think I've solved this before. Yeah, but some time ago. So let's try this again now. So we're given an n by n two-dimensional matrix representing an image. Rotate the image by 90 degrees clockwise, right? So that direction, and you have to rotate the image in place, which means you have to modify the input to the matrix directly. Do not allocate another to the matrix and do the rotation. All right, so I suppose our first step will be to take it to a drawing board. Just let's make sure. Okay, so it's at least a 1x1 matrix, and it's also going to be a square matrix. You probably don't care that much about the values in the matrix, but care about the position. So let's have a quick look at it. Okay, so what are we doing here? So this 1 needs to go here. This 2 needs to go here. And this 7 goes here. So it's really just like rotating the entire matrix as if we were like, if this was like a box, we would roll it over onto this side, right? That's basically what we do. All right, so how can we do this? Well, as luck has it, I remember things from my math classes. And to do a rotation, what you can do is, I think you can reverse the matrix and then transpose it. So how would that look like? Well, if we wanted to reverse the matrix, we could. So if we were to change the order of the rows, we would get 7, right? 7, 8, 9. 4, 5, 6 stays the same. And then 1, 2, 3. So we could kind of get a matrix like that. Oh, this looks horrible, but you get the idea. And now transposing means we just, well, we have to mirror it along its diagonal. So the 9 goes here, the 8 and the 4 change place, and the 6 and the 2. So that would be the transpose step. And elements on the diagonal remain the same, right? And 3. So they're already in the correct order, as you can see here. But we have to flip these. We have to flip these. So yeah, this and the ones that are flipped then as well. The 9 goes down here. The 1 swatches, flips or swaps space with the 9. Then we get the 8 here, the 4 here, the 6 here, and the 2 here. And that is exactly the result that we need. So yeah. And let's just check here. Is it the same? Well, first we reverse all the elements. So all the rows. So then the 9 goes up here. So the rows change place, right? So here you can see the 15 is up here. This is the does it still work here? I hope it does. So let's just do this. We'd have 15, 14. We would have 12. This is after reversing the row order. And then we have 13 to 5. We have 1, 4, 3, 6, 8, 9, 7, 10, 11, right? This would be after flipping the rows. You could also flip the columns, but I think if we put that in the code, flipping the rows is going to be easier. And now we have to change, yeah, so now as you see here, 13 and 14, they have to change places. 10 and the 9, they have to change places. We have the 3 and the 8, they are already in the correct positions. All of the diagonal elements are in the correct positions. Then we flip the 2 and the 12, right? 12 and 2, we have to flip them, etc. The 4 and the 6, 5 and the 16, blah, blah, blah. So yeah, so that's going to be what the approach is, really. And we just have to pay attention to our implementation. I think the flipping of the rows is probably the most straightforward way to do it. And then we have to be very careful with, you know, flipping the elements of the along the matrix. And yeah, so let's see how that goes. Right, so the way to do this is, well, first step is flip flip rows, and then we have to do transpose matrix along the diagonal, and the one that goes from the top left to the bottom right. Okay. And by the way, we can already do a time and space complexity analysis. Obviously, we need to touch every single element, right? So that's going to be n times n time. And well, we don't use any other data structures for it running it. It's a weird key combination, and then it just runs it. Keep pressing it. So that'll be our space and time and space complexity analysis. So how should we do this? For flipping the rows, well, we could do top, bottom, top, bottom equals first row, and the length of the matrix, that's the last row, right? Then we do while top smaller bottom. We could say that matrix top row is equal to swap them. So we're swapping at the bottom and the top. And well, and then we just say top minus, no, plus equal 1, and bottom minus equal. So that would flip them pairwise, right? First and the last, etc., etc. Then it'll iterate until they're both pointing at the same row, in which case we don't have to do. Now for transposing, well, how do we transpose? Well, we need to iterate over all of the elements, right? And we need to swap them. So if we're at a certain position, so we probably need a nested loop, right? Like a row and a column variable. And we probably need to iterate with the row over the length, number of rows in range length matrix. Because it's a square matrix, number of rows and number of columns is the same. And columns. So now we can address every single cell in the matrix with that. Technically speaking, column, get the like so. Well, now we need to swap those elements, right? Matrix at the parent position of row, column. And we're going to swap that against, well, exactly the one that is opposite, right? So we're going to pick the one that is going to be the one that is at row column, because we're swapping the columns and the rows, right? But at the same time, we also have to update that value. So we're doing another swap here. And that is all of that. Yes, and that works because if we are in row 0, column 3, we need to swap with column 0 and row 3, sorry, 2. So this is row 0, column 0, 1, 2. This is row 0, 1, 2 and column 0. So that is how we do that flip. And yeah, and that's really all that is needed. X equals Y diagonal, row equals col. That is the diagonal on which we. So if you run this, we're getting the wrong answer. So why is that? Expected. That looks like an off by 1 error. So this is correct. 7 and 3 are in the correct position. Oh yeah, we are basically doing the swapping twice, right? Because we iterate over the entire matrix. At one point we are going to swap 1 and 9, and then later we're going to swap 9 and 1. So how do we get around this? Well, just make sure that we only swap the elements. So we only iterate over the triangular matrix. Let's say this one, the top right matrix, like so. So we're really only iterating over half of the matrix. And when we do the swapping, if we do that, then that should work. Right. So yeah. So there's a potential for error. Now let's submit this. Go.